start. Okay, so this is about moon's phases. And first thing I want to point out here with my sun overhead projector over there, that any kind of object, especially a round object, is half lit up and half dark. For Earth, of course, we call that day and night. Moon, same thing. No matter where I have the moon, I have a lit up half and I have a dark half. So if the moon is here or here, oops, I have to turn my sun a little bit, or over here, and if you could turn this, thank you, over here or over here, always half of it is lit up. Of course, the side facing the sun is the one that is lit up, and the side facing away is the dark one, dark side. But from Earth, of course, we're seeing different phases. So we're seeing a crescent, we're seeing a half moon, we're seeing a gibbous phase, we're going to see the full moon. And then at some point we're not going to see any of the moon. So that half lit up side there has to come into play at some point. I'm going to start out with the new moon. So if you could move over here, you always have to film from the vantage point of the Earth. So what you see here, of course, is the day side. I'm sorry, the night side of the Earth. And here, you're looking at the sun, and from Earth, you would also look into the blue atmosphere. And as far as the moon is concerned, you wouldn't see anything because there's no light on the dark side of the moon here by definition. And the only reason why it shows up on the film is because we have all this ambient light. You don't have that in space. You only have one light source over there. So here we have the new moon. We just call it that way because it's the beginning of all the phases. But other than that, we don't see it because we're looking at the dark side and we're looking against the very bright background of the atmosphere, blue atmosphere. Okay, I'm going to go over here a few days, like 2 or 3 days. So yeah, you have to move over there. And if this shows up really well, this is what we would see. Hold on. This is the way the moon looks like, actually half lit up. But from that vantage point of Earth, we would see only a little bit of that lit up half, and then the rest would be dark to us. And that's because of the geometry between these three objects. We're here, our vantage point, here's the moon, and over there is the sun, and we're looking at it under some kind of angle, and therefore we see, yeah, what kind of phase? Crescent. The crescent phase, right. Then, a few days later, approximately a week after the new moon and a few days after the crescent phase, we see, well, half of the lit up half and half of the dark side. And we therefore call this a half moon. Then we move on, kind of over here. Now we're seeing quite a bit of the lit up half of the moon and only a little bit left of the dark side of the moon. We call it the gibbous phase. As we go through the motions here, we see more and more of the lit up half. That's why we call it waxing. And then on the other side, we will call it waning. And then finally, after 14 days after the new moon phase, we're going to see the entire lit up half and nothing of the dark side of the moon. And that's why we call this one here a full moon to us. Notice that I don't do this. So film this one here. Whoa, here, can you film the moon? I didn't do that. This year would be a lunar eclipse, but it only happens every 6 orbits. So usually the moon orbits too high or too low, too high or too low in respect to the Earth's shadow. So we don't get an eclipse. And I did something wrong here as far as the order is concerned. I'll fix it here as I go to the other side. So here we see a full moon. Then I move on again a few days later. At this point here, you have to climb over the table, or if you want to just come all the way around, that's fine. So here, what we would see now is most of the lit up half and just a little bit of the dark side, and therefore again we would call it the gibbous phase. And then a few days later yet, we see half of the lit up half and half of the dark side, and we call it again a half moon. And then over here we see just a little bit of the lit up half, but a lot of the dark side of the moon. And therefore again we call it the crescent because we see less and less of it. We call it the waning side here for the phases. the thing that I did wrong earlier is that the moon is orbiting around the center of the Earth. So if I have my moon over here high, on the other side I would have to have it low. So when I'm back to the new moon here, again, I don't get an eclipse because the moon is too low. And over here, of course, I didn't get an eclipse lunar eclipse because the moon was too high. And usually it does that. Eclipses are the topic of another video. The other thing that I perhaps did wrong here, but it doesn't matter, is that the side of the moon with all the Mare, the lava Mare, is always pointing at the Earth. So I should have rotated it slowly, but I didn't pay attention to it because I just wanted to talk about phases. Another thing in here, when we have the phases on this side here, of course you're on the wrong side now, but it doesn't matter. You can stay there. As it orbits over here, we would see it in the evening or late afternoon, and then early evening throughout these days here, and then of course the full moon the entire night. While over here, the waning moon we would see more in the morning hours, so prior to sunrise, and then really in the morning or just prior to sunrise. But that's actually really kind of difficult to explain with this kind of model here. But overall, I wanted to get across that because of the geometry between these three, the light source, the sun, and our vantage point, the Earth, and the way we look at the lit up half of the moon, that's how we get the phases as we see them from Earth.